I would like you to participate as much as possible too. That gives me an idea, gives me feedback that you're getting it. All right. Before we can go and discuss division of fractions, let's first talk about dividing whole numbers, such as 12 divided by 3. Y'all know what the answer is, right? Just say it. All right, good. Let me show you how to model it, because how we model whole numbers is closely aligned with how we're going to model division of fractions. This is called a fraction bar. Think of this as being a whole entire bar that I have divided up into how many pieces? Count them. Luke. 12 pieces, right? Each piece then represents technically 1/12, right? All right. So what we're going to do is when we think of like division, think about putting things in groups of. So when we see 12 divided by 3, we're taking these 12 bars and we're putting them in groups of 3. There's a group of 3. Can you make these little brackets? If not, you could just do this. Might be easier for you. And then once all of my groups are done, I count my groups. There's 1, there's 2, there's 3, and there's 4. How many groups of 3 have we made? And 4 groups of 3 in the number 12. Okay? There's another way we can word it. If we divide 12 into 3 groups of equal size, what is the size of each group? If we divide 12 into 3 groups of equal size, what is the size of each group? Amanda? Correct. 4. If we divide 12 into groups of size 3, how many groups would you make? Each group is 3 in size. Each group is 3 bars. How many groups would you make? Also 4. Okay? Now, how would that look? If you do it as 12 into 3 groups of equal size, there would be 4 in each group. That's how it would look. 3 groups of 4 each. If we do size 3 like we did up here, size 3, that's 1 group. Second group. Third group. That's what it would look like if you model it. All right, what about 12 divided by 4? Think of this number as groups of. How many groups of 4 can you make? Lucas Longo.
3.
3 groups of 4. I'll model it in 1 second. Groups of 4. There's a group. There's a group. And there's a group. For a total of 3 groups of 4. The other way that you can do it, or word it to yourself, is how many 4s are in 12? How many groups of 4 are there in 12? Answer is obviously 3. How many 4 are in 12. Think of groups of, or how many of that second number is in the first number when you make that division statement. Tyler. The answer obviously is going to be 3. Okay? Are we good so far? All right, let's look at our first fraction model on the next page. 8/9 divided by 2/9. Now, I'm just curious. Is there anybody that knows the answer? Nick, do you know what the answer is? What do you got? 8/9 divided by 2/9. Good guess. And what do you think? 4/1. Interesting. What do you think? Just 4. 3/1. 4/9. 4/9. 4/1. Here's how you model it. This is now one bar being divided up into what? Count the pieces. Nick. No, count the pieces. One entire bar has been broken up into how many pieces? 9. What's the value of each piece? 20. I had 1. I've divided that 1, that whole number 1, into 9 pieces. That means that each piece has to be less than 1. Because the whole bar is 1. How much is each piece? 1/9. Put it in the box. I am going to model 8/9 by shading 8 out of the 9 boxes. So lightly shade 8/9. That's how we model 8/9. What do you got? How come you don't have a pencil? Shade lightly. Circle that 2/9, because just like with the whole numbers, take that second number and say to yourself, how many groups of, in this case 2/9, are in 8/9? I'm actually going to write it out. How many groups of 2/9 in 8/9? Just like we did on the previous page. Previous page we said how many groups of 3 are in 12, and we grouped them in groups of 3. Well, now, since each piece is 1/9, I'm going to put them in groups of 2/9. There's a 9th, there's 2/9, there's one group. There's another one. There's another one. There's another one. Do I have any leftover pieces? But they're not shaded, are they? We don't care about that. We needed that to break it up into 9s, but we don't need that pace because it's not shaded. So I have how many complete groups? Giuseppe. 4. Not 4/9. 4. The answer to 8/9 divided by 2/9 is 4. Now, if you said 4/1, technically you're correct also. Because 4/1 is equal to 4, simplified. We did this, we did this, we did this, and we did this. And we did that. Okay? Good so far? It's not too hard because we're taking it piece by piece. But as you know, we build, and we build. do another one together. I bet you can do this on your own. First of all, break this up into how many pieces? Count them.
How many pieces are there all together? Only 12. Piece is going to be what? Each piece.
1/3.
How
Oh,
many
1/12.
1/12. Let's put it in boxes.
Time. Think of it this way. How many 3/12 are in 9/12? Well, how many boxes do you shade first? We're going to model it first. How many boxes do you shade? Joe?
9.
Shade 9. The first number typically tells you how many to shade. Lightly shade 9. Shade 9. Groups of Aiden. Groups of 3 or 3/12. 1/12, 2/12, 3/12. There's one. Any shaded pieces left over?
Yeah.
We're done. What's the answer? Right guy, Levi. 3. Now I'm curious, does anybody see, just from these two examples, do you see the shortcut? Tyler. I think that's just a coincidence. Say it again, because I want to make sure I'm understanding clearly. When we did 8/9 divided by 2/9, the answer was what? What was the answer first? 8/9 divided by 2/9, the answer was what? Tyler? And then what'd you do here? He's got it. He's essentially got it. If the denominators are then all we really need to do is divide the numerators. A little shortcut. Okay, do you notice that pattern? If the denominators are the same, and they were here, they're both not something over 9. If you just take the numerators and divide 8 divided by 2 and forget about the denominators altogether, you get the answer. 8/9 divided by 2/9 is 4. Not 4/9, 4. Same thing here. As long as the denominators are the same, if I take the numerators, 9 divided by 3, I get the answer. There are 3 groups. Okay? 3 groups of 3/12 in 9/12. But we might be getting ahead of ourselves a little bit.
But only when they're the same. You can only do it when they're the same. The denominators
Right.
are the same.
Only if the denominator is the same can you follow that little shortcut. Now, this is a little bit of a curveball here, a little bit of a leap. But if you follow the model, I bet we can do it. Let's do it. We got to make our own fraction bar this time. They don't give you anything. I'm going to do it as a tape diagram because if you do a big long rectangle and you try to divide it equally into I'm not going to tell you how many pieces, you're going to see that it's kind of hard to balance it out. If you want to do it that way, you could, but I'm going to do it a little bit differently. How many pieces do I need? That's first and foremost. How many pieces do I need? Alexandra. I need 9. So the way I like to do it, rather than, don't do this for a minute. Let me just try to illustrate what I'm trying to say. If you do it this way, don't do anything yet. I know I need 9 pieces, right? 1, 2, 3, 4, 5, 6, 7, 8. I have this whole piece that this just bothers me. I have a piece here that's bigger than the other ones. It's hard to do it equally, okay? So what I like to do, and just kind of make, because I like the pieces all look nice and even. I don't know, maybe I'm a little crazy. I try to do it this way because I want the pieces to be even. Even though, 1, 2, 3, 4, 5. How many pieces do I need? Count with me because I can't count. How many is that?
4, 5, 6, 7.
All right, there's 9. Doesn't look any better than it did before. Each piece is worth what? 1/9. Get ready because the leap is coming. Shade how many? Amanda. Okay. Get ready because the leap is coming. So far, so good. Put them in brackets or groups of
3.
Agree? 3? Get ready because the leap is coming. Watch what I'm going to do. Do I have enough for a third leap? Or a third group? It's called a partial group. Watch what I'm going to do. I'm going to take that leap of 3 boxes, but it's a partial, what we call a partial leap or a partial group, because not everything in this last group is shaded. Does everybody see what I had to do on that last one so far? Okay. Watch what we're going to do. Because it's not a complete group. I want to indicate that it's not a complete group because out of this group, only 1 box is shaded. We put them into groups of 3, but there is a remainder. And we show it by a dotted line. Get ready because the leap is coming. I'm going to cut to the punchline and ask you if you know the answer. And if you're not sure, take a guess. Take your best guess. I'm curious to see. Right guy Levi, what do you think? 2.1. Can you give it to me as a fraction? 2 and what? Give me. Okay. Thorny. 2/3. Will. 2 1/3. 2 1/9. 2 1/3. 2 1/3. 2 1/3. 2 1/3. Now it's just throwing it out there because everybody said 2 1/3. Okay.
So I have a different answer.
What do you got?
2 1/9.
How many think it's 2 1/9? How many think it's 2 1/3? Do you agree I have 1 complete group?
Yes.
Do you agree I have 2 complete groups? Out of this last group, how many blocks are shaded? 1 block is shaded, right? out of how many total blocks in the group? 2 and 1/3. It is because a lot of times kids want to say 2, and what do I have left over? Oh, I have 1/9 still shaded. They want to say 2 and 1/9. It's not 1/9 because think that partial group, one block out of 3 possible blocks in the group are shaded. So the answer is 2 and 1/3. Okay? Good so far? Now here's something that's interesting. What was the rule that I told you that if the denominators are the same, what could you do to get the answer without having to do the model? What's the shortcut again? Luke? Let's just see if it works because we're curious. 3 into 7. 3 goes into 7 how many times? What's 3 times 2? 1 left over, 2, and 1/3. The remainder is the numerator, and outside the house is your denominator, 2 and 1/3. Now notice what's happening is don't get it confused back in the last module where we had to go to termination. We're not dealing with decimals anymore. And it happens to be, in case you're curious, 2.3 repeating. It'll go on forever. It's the cat chasing its tail. All right, we already talked about this, the shortcut. Look for common patterns. If we use the denominator trick, 8/9 divided by 2/9 was what? Just say it. No. 4. Common mistake. 9/12 divided by 3/12. And 7/9 divided by 3/9. Kind of gave this away a little bit, but that's okay. Okay, I did. Yeah, I did. I forget what's ahead. That's why I go on and I forget what's on future pages. But what do we notice? The numerator is the when you look at the numerators, what do you know? If you divide just the numerators, you get the answer. Never seen somebody so eager to finish up a test.
I want to eat. I'm hungry.
All right, let's finish this up. All right, exercise 1, they actually put it in word form. How many fourths are in 3/4? A fourth is what fraction? If I tell you this, a fourth, what's the fraction? 1/4, okay? Now, here's what you have to decide. We know that this is 1/4, and 3/4 is... How do you write that as a division statement? Is it 1/4 divided by 3/4, or is it 3/4 divided by 1/4? How many fourths are in 3/4? What goes first? Gabby. Right, 3/4. Divided by 1/4. Does it?
Yeah.
Oh, it helps you out. Work smarter, not harder, right? Okay. Fraction bar. How many total pieces do I need? Joe, let's make it. Thank God, only 4. At this point, we know that each piece is worth how much? Let's leave it off. We know that each piece is 1 out of 4 or 1/4. How many are we going to shade? Shade how many? Aiden? Right. if it helps you, this first number always tells you to shade. Groups of, Gabby, only one. Groups of one. 1, 2, 3. 3/4 divided by 1/4 is? Answer? Stebby? What's the answer? 3. Does it follow the numerator trick?
Yeah.
Yep, 3 divided by 1 is 3. It works. All right? To be continued. Here we go. All right, 4/5 divided by 2/5. How would you phrase that as a how much or how many blank in blank? Come on, focus. I want to see more hands. Think about it. What's the question asking? How many what or in what? This is better. Aiden.
What?
How many 2/5 are in 4/5? So if you look at it, technically, the numbers get reversed after you put it into that statement, right? You started out with 4/5 divided by 2/5, which is in essence asking how many 2/5 in 4/5. It gets flipped, if you can remember. Fraction bar divided into how many pieces? Participate. If you don't have your hand up, that means you don't know it. Divide it up into how many pieces?
5.
Okay, let's do it. Divide it up into 5 pieces. Beck, how much is the value of each piece? Put it in there just so you can see it. Eventually, you may not need to do this, but for now, it's visual, so you'll see each piece as 1/5. Shade how many? Stays. Correct. Okay, if it helps you, look. This first number is always going to be your shade. All right, there's my 4. Group by Lucas. Second number is always going to be the group by. God bless. That's it. I have a little piece that's left over, but it's not shaded, so I don't care about that. How many groups did I create when I put it into groups of 2? Jojo. Yeah, I made 2. There's 1, there's 2. Therefore, 4/5 divided by 2/5 is 2. Not 2/5, just 2. Okay? Ready for another leap? Something that's a little out of the ordinary with one of those fractions. Do you notice it? 9/4 divided by 3/4. What do you notice about one of those fractions? Well, yeah, what's it called? What kind of fraction is it when the number is what we call a top heavy, or the numerator is bigger than the denominator? There's a name for that type of fraction. It's called an improper fraction, right? Which is, in essence, means that that fraction is a value that's greater than 1. 9/4 is a value that's greater than 1. Before we model it, though, still think of it the same way. How many what in what? Joe. Okay, that does not change. Keep it the way it is. How many 3/4 and 9/4? Now comes the all-important question. How many pieces do you need? How many pieces do you need? Gab, what do you think? You say how much? 4, what do you think? 4, what do you think? 9, what do you think? 9. 3. 9. 3. We're all over the place. 9. What do you think? 4. Let me just tell you the answer and we'll work backwards. You need 9 pieces. If you got 9, you guess 9, you're right. Let me show you why, though. I think it might help you to work backwards to see why it's 9. Take 9 boxes. Trust me. You'll see why we need 9 after we model this. I got one too many. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? All right, now ready? How much is each piece worth? Be careful. Brando, what do you say? Let me say 1/9. Let me say something different. M, what do you think? Let me think 1/4. How many think 1/9? How many think 1/4? All right, majority rules. It is 1/4. I do want you to put 1/4 in every box for this particular question because I want you to see what 9/4 looks like. Remember that first number is always my shade. Okay, ready? Watch. I've shaded how many fourths? 1/4. 2/4. 3/4. 4/4 or 1. 5/4. 6/4. 7/4. 8/4. 9/4. Do you see now why you need 9 boxes? Does that help you to see a little bit better? Yep, you got to shade all of them. The hard part's done though. Knowing how many boxes you need, because they're all going to wind up getting shaded, but knowing how many boxes you need is the hardest part. Because everything else now follows exactly what we've been doing all along. Groups of, Alexandra. Yep, groups of 3 or 3/4. Because I only made as many boxes as I need to shade. You'll see when we get even more advanced, there'll be more boxes than what we need. When we have what's called partial, or like kind of like what we did where we had that remainder of 2 with 2 1/3, you'll see, we'll get to that, where you're going to make more boxes than you need because there'll be partial leaps or partial groups. But right now, the way it works out when I put them in groups of 3, it's exactly 3 groups. So Joe, you were kind of right. You kind of leaped to the end there and saw that 3 there because that winds up being our answer. Okay? I'm going to model this using a number line. Some of you are going to like number lines better than I think than shading. It is less work, but there's another way to model this using a number line. This might be different from the way Nat did it. I don't know. Okay? Same problem. 9/4 divided by 3/4, right? Underneath this, I want you to make a little note. This is my go-to. And I want you to circle this and call this my leap by. Leap by. Because you're going to leap rather than group. think of a number line. You're going to leap on your number line. Where you need to go is your first number. What you're leaping by is your second number. So on this number line, where do I need to go to? It's already been divided up into fourths. There's a fourth, there's 2 fourths, there's 3 fourths, 4 fourths. This is actually technically the whole number 1. This is the whole number 2. But where do I have to go to according to the division expression? Rando. I got to go to 9 fourths. I want you to put a line here so you can see it. That's my go-to. This is kind of already done for us, but that's all right. Leap by, which is the same as groups of, leap by 3. So look, here it is. It kind of shows you. Here's a leap of 3. Then I leap again. And then I leap again. And I got 3 total leaps. Obviously, you get the same answer. Instead of doing boxes, you're doing number lines. You'll see this is going to come in more. You'll like this more, I think, as we get more advanced. All right. Do one more together, and then I'm going to group you. Ready? How many what and what? Come on, somebody I haven't heard from. How many what and what? Tyler. How many boxes do I need in my model? Do you want to do number line or no?
No.
How do I do number line?
No.
How do I do boxes? Or I'll do boxes. How many boxes do you need?
8.
You need 8. Each one having a value of 1/8, but guess what? We'll take a shortcut. Don't put 1/8 in each box because you now know each is worth 1/8. Shade how many? Back up. Good. Shade 7. Groups of. Groups of. Lucas. 2/8, or 2. There's 1. There's 2. There's 3. Do I have a complete fourth? Dotted line. Know what our answer is? Suresco. Let me think 3 1/2. Let me think 3 1/8. What do you think? 3 1/8. What do you think? What do you think? What do you think? 3 1/2. What do you think? 3 1/2. 3 1/2. 3 1/2. 3 1/2. 3 1/2. 17.147. All right, let's see. I have 1. I have 2. I have 3. And out of my last group of 2, I have 1 shaded. 3 1/2. 3 1/8 is a common mistake. It's not a leftover boxes. How many are shaded out of that last group? Okay. All right, you ready? You want to go into groups? Okay, here's how it's going to divide out. Go back to the original page.